The first thing you want to do in the Extreme Reactors mod is, of course, build a reactor. So let's look at building our first ever reactor. So the first thing you're going to need is some yellorite ore. This is pretty much in all dimensions and shouldn't be too difficult to find. If you simply then smelt it up in your furnace, you will get yellorium ingots. Or maybe if you're playing in a mod pack, you'll actually get uranium ingots, depending on if the mod pack has changed them. And you can see here it says yellorium ingot accepts tag uranium ingots. So it's often very interchanged. Another thing you will need to make is graphite bars. This is usually made by just smelting up coal into graphite, so very simple there. There is also another ore called anglicite, which you'll find in the end, and bonitoite, which you will find in the nether, but we're not going to look at those just yet while we're making our first reactor. So what items will we need to build our first reactor? Well, we will need reactor casing, and you'll notice here that it says basic around it. The basic reactors that you'll be making as your first reactor can only be a maximum size of 5 by 5 by 5. There are later reinforced components which are much more expensive to make, as you can see, needing steel and blocks of iron. And in some mod packs it may even need blocks of diamond, etc. Those ones can be made into a size of I think it's 48 times 48 and 32 tall or something like that. But you can change it in the config, and some mod packs will allow you to make gargantuan reactors. But with the basic platings, the biggest you can make is 5 by 5 by 5, which is what we're making as our first reactor. So let's start off with the casing then. I'm going to make, as an example, a 5 by 5 by 5. You can also make, for example, a 3 by 3 by 4, for example, which is just small like this. So you really can make these whatever size you like. So let's make a 5 by 5 by 5. Honestly, making a 5 by 5 by 5, which is the biggest you can make a beginner reactor, isn't going to be very expensive for you. And it's probably what I would do if you have enough yellorium, which isn't going to be a crazy amount. You may as well just go ahead and make this size for your first reactor, in my opinion. Of course, you could make it smaller and upgrade it later. It's entirely up to you. But making one like that, you don't really have much space to really play around with it, which is a lot of the fun that you'll be having here. So I'm just going to put most of it as reactor casing. You can also use reactor glass for the walls, which I'm going to be doing on this side, just so that we can see into the reactor. Cool. So first of all, you'll need a reactor controller. Again, a basic one. This is how we will actually open up and look at our reactor on the inside. We're also going to need some fuel ports. 1, 2, 1, 2. These are called reactor solid access port. This is where you will be putting in your yellorium ingots, and you're also going to get some waste out of your reactor as well. So on the second one, I'm going to click outlet mode. You can see it's turned to green. So the solid access port basic one is an inlet mode, and you can pipe in your yellorium from another mod's pipes, for example. Maybe I'd use logistical pipes from Mechanism and pump in my yellorium from a chest or my applied logistics network. You can also eject the fuel contained in the reactor, placing ingots in the reactor solid access ports, or you can eject the waste. And in here, I'm saying this is where we want our waste to go, and you can pipe this out to wherever you're going with it. You could store it up for later, by the way, because there is something called a reprocessor that we will be using later on, but not for our first reactor. Then we need to say, well, where's the power going to come out of? Okay, I'm going to add a reactor active forge energy power tap. This is where you would put your power cables to actually store your energy and pipe out energy from the reactor. Last thing is actually the fuel rods. We have reactor fuel rods basic. What I'm going to do is go 1, 2, 3, 4, 5, and then 1, 2, 2. Yep, just 2, like this. This is where the reactor is going to insert the fuel into. On top of these fuel rods, you put reactor control rods on the top, and they would go on the roof of the fuel rods. And I'm just going to end this off with some more plating. And you can see it has changed into a multi-block. You can see that the fuel rods are now full of yellorium. If we go over to our controller, You can see the fuel rods, 15, max capacity, 60 buckets. Waste is empty. And there's a lot of information going on in here. So if we now go into our access port, you can see it's used up 60 out of 64 ingots. Now, it's quite a lot, obviously, that we're using on a reactor of this size. So depending on how much yellorium you have, you may not want to be using this much yet. It's not going to use all 60 of those instantly. It will be burning them quite slowly. So let's have a look inside the reactor and see what we can see. So you can see the red is showing the reactor is inactive because it is turned off. We can turn it on here. We can void all of the reactants present in the reactor, which is the yellorium here. We can say, do we want the waste to be automatically ejected or manually ejected? So you'll often see manual and automatic in extreme reactors. It's quite simple. Automatic means if I have a pipe attached to here, the reactor will push it out if it can, or it'll pull it in if it can. Manual means that the pipe attached will have to do the work and will have to basically request the item. That's all it really means. So if you're, say, using mechanism pipes and they are set to pull, then manual is fine. But you can still leave it on active. It's completely up to you. Whereas active will push it into the pipe without the pipe needing to pull it out itself. So let's have a look at what we can see here. We have the core fuel status. It's 100% fuel. None of it is depleted. And we can see how much fuel is in the reactor. Then we have the core heat of the reactor. Heat of the reactor's fuel. High heat raises fuel usage. So the higher that the core is, which is your fuel rods, the hotter they are, the more heat it's going to burn through, and the more fuel it's going to burn through. Meaning your yellorium in there is going to burn through really, really quickly if the core is at a really high heat. The core heat is transferred to the casing of the reactor. Transfer rate is based on the design of the interior. Casing heat. Heat of the reactor's casing. Higher heat raises energy output and coolant conversion. This reactor here is passively cooled. So we're not adding any active coolants like water into it to actively cool it. So what you want here is a really hot casing because it's going to increase the energy output, but you want your core to be a lower heat because the higher the core, the faster you're going to burn through fuel. And then we have the internal energy buffer. This is just showing how much energy that you are making in your reactor. If the buffer is full, any newly generated energy is going to be lost. We've also got temperatures down here, which basically tell us the same things that I've just shown you. The core heat, heat of the reactor's fuel, again, goes to the casing. The fuel burn-up rate, the rate at which fuel is fissioned into the waste in the core. This is how quickly you're burning through your yellorium or uranium. Fuel reactivity, how heavily irradiated it is. Higher levels of radiation reduce fuel burn-up. And how much are you actually making? The reactor is passively cooled and generates energy directly from the heat of its core. Any amount of energy that could not be stored in the internal energy buffer is lost. So when we turn it on, what you're going to see is the heat of the core getting really, really hot, and the casing getting hotter as well. And of course, we're burning up energy. And you can see we're using 0.1 millibucket per tick of fuel. We can also press an emergency shutdown, turn off the reactor, and push the control rods all the way into the fuel rods and hope for the best. So one thing I haven't mentioned yet here is if we go into our reactor control rods, what you could do here is you can see it's 0%. I can up this by pressing the tick, pushing the fuel rod down into the reactor, and by meaning that we're using less of the control rod. The higher the percentage, the less fuel you will be burning. That's what we're basically doing. We're basically at 0%, we're using the entire length of our fuel rod. Oh, sorry. I'm using my WASD weird because I've got a really bad cut on my finger. That's why I'm like throwing stuff all over the place because my fingers are not used to where the buttons are. So at 0%, you can imagine we're using the whole length of this and therefore maximum fuel usage. If I press Control, I can go up in 10% intervals, and Shift will take me all the way to 100%. That one is just for that fuel rod I'm doing. You can say change all, and it will change all fuel rods in the reactor to 100%, etc. So just doing it, basically imagine it like 30% I'm only using these two. At 60%, I'm only using this one because it's pushed it down all the way here. And at 100%, I've basically pushed the fuel rods all the way down, so it's basically inactive. So I can change it all. I can go shift to 100%, change all, and they're now all at 100%. And what you'll see in here is that the reactor is cooling down because we're not really doing anything. We've pushed the fuel rods all the way down so that we've shut off how much fuel is being injected. Or I can say shift to 0, change all, and it's going to change all 5 of them. And now you can see the heat is going back up. So that's how you can kind of, even with a big reactor like this, actually control how much you're using. And that's why I say you might as well just go ahead and make a 5x5x5 as a basic reactor, because you can actually still control how much you are using in the reactor. Now, it does matter how wide and tall you make your reactor. The wider you make it, is going to make it more efficient because there's more cooling going on, especially when you have an active coolant, which we're not talking about in this part of this tutorial series. The taller you make your reactor means it will make more power, but it will burn more fuel because you can have longer fuel rods. So the wider it is, the more efficient it can be, as long as you don't add more fuel rods to the design, of course. Like I could just have one fuel rod in here. I don't have to have all 5. And the taller you make it, the more fuel rods you can fit in there, and therefore the more fuel burn rate and higher energy you can produce. This reactor design here, quite basically, is making about 3K forge energy per tick, for example. And that is your first reactor complete. The only other thing to mention is, of course, that you must be putting in your yellorium, piping that in, and then you will get some waste out of the reactor as well. The waste that you will get is called cyanite here. And you will need this cyanite, which is a waste product from your reactor, later for building something called a turbine or your reprocessor casing. But I'm not going to go over that in this first reactor part. And there you go, guys. You have officially built your first reactor in Extreme Reactors.